we're comparing the elements of H and Li. So the highlighted features are in the middle in beige, like here, the Bohr model. So it says draw the Bohr model. So you can see we have drawn them. You don't insert a picture. You'll be physically drawing them either on paper or an edge elastic. Next, so you're going to pick only one of the columns to answer for both elements. So for both elements, either you're going to answer on the left or the right side. So the first feature is the location of the valence electrons. Where are they? Are they in the same shell? Or are they in different shells or energy levels? So we have to look at our Bohr models. We can see that H has an electron in this first shell. And then lithium has electrons in the first and the second shell, but the valence electrons are in different shells. So they're in the second shell. So the answer for this first feature, the location of the valence electrons, is that the valence electrons are in different shells. And we write that for both elements because we're comparing them. So since we know they're in different shells, we go down this way in the chart. We ignore the other side of the chart because they are not in the same shell. We've identified that the valence electrons are in different shells. So the next feature that we look at is the distance of the valence electrons to the nucleus. Is it near or far? Okay, so we go back and look at our models, and we see that hydrogen's valence electrons in the first, lithium's in the second. So hydrogen has valence electrons that are nearer or closer to the nucleus, whereas lithium has valence electrons that are farther from the nucleus. Okay, so now that we filled out that part of the chart, we're going to talk about the attractions between the protons and electrons. And once again, we follow down the columns. So more protons and electrons mean a strong attraction, but we're not on that example. We're on near and far. We know that if the valence electrons are near the nucleus, there'll be a strong attraction. Far away, there'll be a weak attraction. And how do we know that? We learned from the simulations in the edge elastic about the relationship between the distance of the valence electrons from the protons in the nucleus and the strength of attraction. Okay, so since for hydrogen, the valence electrons are near the nucleus, that makes them have a strong attraction between the protons and electrons. Whereas for lithium, the valence electrons are further from the nucleus. They will have a weak attraction between the protons and electrons. Yay, we're almost done. So now that we know about their attraction, we're going to decide about how their sizes of their atoms or the atomic radius will compare. So we know if there's a strong attraction, the atom will be smaller. And if there's a weak attraction, the atom will be bigger. So we know that there's a strong attraction for hydrogen that will give it a smaller atomic radius. And for lithium, bigger atomic radius since there's a weak attraction. And if you look at your example that you did in the activity, it's in the cards, you will see that where hydrogen is, that is smaller than where lithium is because lithium is under hydrogen in the periodic table. All right, so what are you going to write in your notes? This is a shortened table in your notebook. This is what you're going to copy. That way you can use it on a test, quiz, or when you're doing homework. Please copy this example, which is a shorter version of the previous one. Why are we making this graphic organizer or table? So we can write our answer to a question. So this question is, which atom is larger? Which atom is larger, an atom of helium or lithium? Did I say helium? I meant hydrogen. Sorry. I think I had a typo. All right, there we go. Fixing it. Write a sentence using the information in the table and state the evidence, okay? So here's your example answer. Hydrogen and lithium have valence electrons in different shells. H has valence electrons in the first shell and lithium in the second shell. We call that our evidence because I'm stating where the electrons are located. So in lithium, the valence electrons are farther from the nucleus than H, hydrogen. This means that lithium has a weaker attraction between its protons and electrons than H. This means that lithium is a bigger atom than hydrogen. And we get all that information from this table above.